good to go. Okay, good morning. Today is April 1st. Happy April Fool's Day. This is not a joke, though. We are doing some Algebra 2 right now. Just a couple quick reminders before we get started. Remember to please fill out the attendance form on Classroom if you haven't done so already. It's the same Google form. Just go ahead and click it in the morning. A couple other people jumping in right now, which is fantastic. Make sure if you would like to have that tab opened in a new tab of the actual worksheet that was due today, Distance Learning Days 4 and 5 radical equation word problems. I did ask you to please complete the first 5 problems in preparation for today's class. I'd like to go over a couple of those problems with you, and then I'll show you a couple other applications. For next time, I am asking that you complete 6 through 10. Okay, so you'll have a couple problems to do for next class as well. Hopefully, like I said at the beginning, as more people jumped in now, so I want to repeat it. Hopefully you did get my email from yesterday. I sent a long email. I apologize for it being so long, but I just wanted to be as clear as possible as to our schedule for the next couple of days going forward. We do need to have another progress assessment and another summative assessment prior to the end of the quarter. So I tried to spell out as many details as I could for you on what the PA will look like. The summative, a couple of teachers and I are still kind of talking about what we want the summative to look like and how we want it structured. So I will be able to get back to you with more details when I know what we're going to be doing. We just want to make sure all the Algebra 2 people are all on the same page, so that's good. The summative is going to be scheduled, though, for our class on April 14th. I believe that's a Monday or a Tuesday. I'm going to look at my calendar right now. April 14th. Oh, sorry. Yeah, there it is. It's a Tuesday. So Tuesday, April 14th is the scheduled day of our summative assessment. It's going to cover all of the graphing stuff and all of the equation stuff that we talked about with radicals. It is something that you are going to be required to do on that day. Like I said, I don't have any details for you right now as to what it's going to look like. What I'm thinking, this is just an off the record, even though it's being recorded, but this is just what I'm thinking it might be, is something where I post it in the morning, either on Google Classroom or send it out via email. I just literally say, here's the test, and maybe give you the rest of the day, because I know you have other classes and you have other work to do to complete it, and say hey, it's going to be posted at 8 a.m. Can you submit it by 6 p.m.? And in order to submit it, I am going to require that you take a picture of your work and send it to me via email. And I think that's definitely a fair thing. That gives you enough time to do it. It's not just because I'm giving you 10 hours to do it doesn't mean it's a 10-hour test. That would be miserable. It's the same length of summative that you would normally have in any standard Algebra 2 class or any standard math class. It's meant to take about 45 minutes. But I know there's a lot of stuff going on during the day. You have other classes, you have other work. There's unforeseen things that can happen at home for sure. And so I thought that was a pretty fair thing to say hey, it's going to be posted at 8 o'clock in the morning on April 14th. You have until 6 p.m. that day on April 14th to do it out, take a picture of it, and send it back to me. I think that's more than fair. If you have any concerns, though, I'm more than willing to discuss it with you. I want to hear from you. At least type it in the chat so we can address it. If you're I don't think that's fair because of X, Y, and Z, and I'm happy to take that into consideration. Or if you're hey, that sounds pretty good to me, that seems reasonable, such and such, then so be it. All right, but I just wanted to give you a little pulse of where we're at. All right, anyway, let's jump right into some teaching with our Algebra 2. All right. Today, like I said, I'd like to go over a couple of the word problems that I asked you to do for homework, as well as just show you a few more today. I'll probably get through about 4 problems today was my goal. And then, like I said, I am going to ask you to complete the remaining word problems, 6 through 10, for homework. Hopefully it went pretty well, though, because I really like these problems, because now that we've learned how, I like a lot of math problems, no, let's be real, but especially now that we've learned how to deal with radical functions and equations, these provide some really interesting twists on other types of problems you've seen in other math courses where you're solving for information that you may not be used to solving for. For example, I want to do another one of those distance formula problems because those are a really prime example of working with radical equations. For example, something like number 3 on that homework assignment. It said the following. Number 3 said the following 2 points are given. You're given the point x comma -7. We don't know what that x is. And you're also given the point of -5 comma -8. And you're also told that the distance between these 2 points is the square root of 10. Okay? And your job is to find the missing x coordinate. Well, you may remember, and by the way, if you ever need the distance formula or any formula in any sort of assessment, it will be provided to you. It is not your job to memorize that. That's outside of the scope of this class. Hopefully you did that last year in geometry. So the distance formula is given to be the square root of x2 minus x1 squared plus y2 minus y1 squared. I know actually on the homework assignment it writes it backwards where you see it's y2 minus y1 squared plus x2 minus x1 squared. It doesn't matter because you can add in either order. So you could write y2 minus y1 squared plus x2 minus x1 squared. It's the equivalent. All right, so just going ahead and filling in our values here, I'd say that my distance is the square root of 10. And I'd say that's equal to the square root of, let's call this my x2 and y2. Let's call this my x1 and y1. All right. X sub 2, which is negative 5, minus x sub 1, I don't know, squared, plus. Y sub 2 is negative 8 minus y sub 1, so minus negative 7 squared. And now I could just go through my solving process in order to actually find what x could be. I see this big honking radical here covering everything. I don't like that, so let's go ahead and get rid of that by squaring both sides. If you notice, that square root of 10 is going to become a lot less scary too, because the square root of 10 squared is just 10. The square root and square cancel out over here. I get negative 5 minus x squared plus, just a little bit of calculation over here, negative 8 minus negative 7, so that's negative 8 plus 7 is negative 1, and negative 1 squared is positive 1, so plus 1. All right, hopefully everybody understands how we got to that step. All right, going forward from there, I can now do a little first, outer, inner, last on this piece. That becomes 10 equals negative 5 minus x times negative 5 minus x, right? Take that and multiply it by itself and then add 1. Let's go ahead and distribute. I get 10 is equal to, that's 25 by doing the first. Outer and inner, that's going to be plus 5x makes a total of plus 10x. And the opposite of x times the opposite of x is positive x squared. And then plus this lingering 1 on the outside there. Once again, you should see this x squared show up. And as soon as you see x squared show up, that is a prime time indication that we need to factor. But of course, before we factor, we need to set equal to 0. So I'm going to subtract this 10 over to the other side and combine the 25 and the 1. So that altogether comes out to be, if I rearrange my terms in a nice familiar order, x squared plus 10x, and then what do we got? 25 minus 10 is 15, plus 1 is plus 16. Okay? And now from here, we just do a little bit of factoring. In order to break down that quadratic expression, we need x and x to multiply to x squared. Everything's positive, so I'm going to keep my signs positive. And now we're looking for factors of 16 that will combine to give me my 10. That's 8 and 2. All right? So we get our two solutions here, that x could be negative 8 or x could be negative 2. Both of those are acceptable because those would just represent drawing a line that has a distance of the square root of 10 units in two different directions, right? So that would be how it's done. Any questions about that at all? Hopefully that made a lot of sense. Feeling good? All right, I take your silence as, yes, Mr. Giorgio, seems great. All right, let me do another one for you. So not only are there formulas that we've seen in math classes, like the distance formula or the quadratic formula, there's other ones too, like something like problem number 5, if you noticed, was just this random formula that was given to you. It didn't require any specific background knowledge to do. You know all the algebra required to solve something like that. It says, in a thunderstorm, the wind velocity, represented by v of p, in meters per second, is described by the function v of p equals 5.7 times the square root of 998 minus p, where p is the air pressure measured in millibars. What is the air pressure of a thunderstorm in which the wind's velocity is 49.3 meters per second, and it says round your answer to the nearest tenth of a millibar. So if you notice, again, there's a lot of meteorological, that's a big word, background going on with an equation like this, but you don't need to know any of that in order to solve this. We could just go ahead and say, well, your 49.3 is your v of p, and that's equal to 5.7 times the square root of 998 minus p. Okay? Now, just like I'm used to, I'd want to isolate that radical and solve, right? This is just a standard equation. I'm going to divide by 5.7. Let's use our handy dandy calculator. We got 49.3 divided by, divided by 5.7, and we get our 8.6, we'll call it 8.65, is equal to the square root of 998 minus p. Now to get rid of that radical, because eventually we want to get p equals, right? Let's go ahead and square both sides. We have 8.65 squared is 74.82, which makes sense, by the way, right? 8.65 squared should be somewhere between 8 squared, which is 64, and 9 squared, which is 81. So that answer of 74.62 makes a lot of sense. And that's equal to 998 minus p. Just a little bit of quick algebra right at the end here. Let's subtract 998 from both sides. We have our 74.82 minus 998 is equal to negative 923.18. And that's equal to the opposite of p. So think about it. If the opposite of p is equal to the opposite of 923.18, dividing both sides by negative 1, you would get that p is equal to 923 rounding to the nearest tenth, because that was the instructions given, 0.2 millibars. Okay. Does that make sense to everybody, hopefully? Yes, we see where that came from. We see how that was done. Excellent. Fantastic. All right. Let's go on to a couple different types of word problems. If you notice, problems 5 through 10, I don't know if you managed to get like a little sneak peek ahead or you managed to preview them. They involve a couple other random formulas too. So I just want to show you a couple other problems that may or may not be based in the formulas we've done before, right? Like here's a great one from physics. Right? You may remember from physics, and you might be like, oh God, physics. Again, you don't need the background necessarily to solve these problems. You really just need the algebraic processes associated with them. So you may remember this from physics, that if you have an object in motion, the velocity of that object is equal to 2 times its energy, times its kinetic energy divided by its mass. That's a formula from physics. That your velocity that an object is traveling is equal to the square root of 2 times its kinetic energy divided by its mass. If you didn't do that in physics, well then that's a formula that you now know from physics. And suppose you had a problem like this. Say like an object with a mass of 100 kilograms is traveling at a rate of 30 meters per second. Find the object's kinetic energy. Right? So again, the physics background is somewhat irrelevant here. We just need to be able to use this idea, manipulate that equation, and solve for what we need to solve for. So I'm going to go ahead and do exactly that. Let's plug in what we know. I know that my velocity is 30. I know that that's equal to the square root of 2 times the kinetic energy, which I don't know. That's what I'm trying to solve for, E sub k. And the mass is 100. And now it's a matter of just manipulating this equation to find the solution. I can go ahead and square both sides. 30 squared is 30 times 30 is 900. The square root and square cancel out over here, so I get 2 times E sub k over 100. We can go ahead and multiply both sides by 100. You're going to get 9,000. Oh, sorry, 90,000. 9,000 would be if you multiply by 10. Equals 2 times E sub k. Dividing both sides now by 2, you would get that your kinetic energy would be 45,000. And there you go. Make sense to everybody? Even though it's a physics formula, even though the background knowledge of where that formula comes from may be based in physics, you don't need any of that to solve it. We're really just focused on the algebraic processes here. Okay? questions, comments, concerns about this? All right, one more word problem that I want to show you to wrap up the day here. Consider something like this. If I have, we'll go back to a concrete math example. If I have a right triangle, something you may remember from geometry is that if I call this leg A, this leg B, and the hypotenuse C, you may remember our good old friend, the Pythagorean theorem. The Pythagorean theorem states that the legs squared, A squared plus B squared, the sum of those, is equal to the hypotenuse squared, right? A squared plus B squared is equal to C squared. That's one of those classic geometry formulas, right? Something that you could actually do to this formula to get C directly is, couldn't I take the square root of both sides and say that an equivalent formula to this would be the square root of A squared plus B squared is equal to C. That's true, right? Because C squared, square and square root will cancel out. And so this is really the same formula as what was just described above. A squared plus B squared equals C squared. It's equivalent to saying the square root of A squared plus B squared should equal C. I think that makes sense, right? So this formula, I'd actually argue, now this is a controversial math opinion alert here, I actually would say that this formula is a little more useful even than this formula, because this just gives you C directly. You just literally have to plug in. There's no algebraic manipulation required. You just plug in. So I think that's like the hidden super useful Pythagorean theorem. But anyway, don't tell anyone. So now we go ahead, I don't want to upset the mathematicians. Now we go ahead and look at a problem maybe like this. What if I told you that consider this formula, if I said the hypotenuse of a right triangle is 30, we'll call it centimeters, okay? If one of its legs measures 18 centimeters, find the length of the other leg. Okay? So how about a problem like this, where now we're just saying, use this formula, plug in what you know, and solve for what you don't. The hypotenuse is 30, so I'm going to say that 30 is equal to the square root of. One of the legs is 18. We'll call that A. 18, right? Say that's 30. Plus B squared, because we don't know what B squared is. And now we can go ahead and just use the algebra that we've learned to solve for B. I would start by squaring both sides to get rid of that big square root, giving me that 900 is equal to, get rid of that, 18 squared is, refer to our handy dandy calculator, I don't know that off the top of my head, 18 squared is 324 plus B squared. I can now subtract, this is just algebra 1, subtract 324 from both sides. You get 900 minus 324, I'm just plugging it into a calculator right now, is 576, is equal to B squared. Lastly, take the square root of both sides, and you would notice that B is equal to the square root of 576, I think is 24. Let's find out. It is. And so that's how you could find out the length of the other leg. All right. Does anyone have a question on any of these applications that I've presented to you today? Again, it's just like different ways that you can apply what we've learned with these radical equations to be able to manipulate them accordingly. So we're all happy with that. We're all feeling good. Nobody has any questions at all. Not even a single question. No questions. Holy cow. Well, I guess it must have been really clear then. So that's great. All right, very good. So let me now, since we have a little bit of extra time right at the end of class, I got through the 4 problems I wanted to show you. Let me go ahead and show you just another equation, just so we can make sure we refresh and review on our concept of equations. We don't want to lose that now that we're heading into word problems, okay? So I just want to show you another equation that is good here. I got to get a fresh sheet of paper. Let's get a fresh sheet of paper. All right, let's go ahead and solve some equations. All right, just a little review of another equation. Can never hurt to see multiple equations, right? Can never hurt to have more equations. What if I gave you something like this? Well, I'm trying to find a good one. I must have a good one near me. I must have a good one nearby. I gotta have a good one nearby. Oh yeah, how about this? How about this? Here we go. Ugh, get all these papers out of the way. I've got to really organize my workspace here. Okay, we got another little review of stuff that we've been doing. Something like this. Let's do, sorry, it took a little while. How about x is equal to 7 plus the square root of 39 minus 3x. Okay. Standard problem as always. Again, just going back to our solving equations now, just to make sure we recap and refresh that idea. I can, in order to solve this, we want to isolate that radical first. We want to subtract 7 from both sides. I get x minus 7 is equal to the square root of 39 minus 3x. We can now go ahead and square both sides in order to get rid of that radical. Square and square root would cancel out. I get x minus 7 times x minus 7, because we have to do a little distributing on that side in order to make that equal, is equal to 39 minus 3x. First outer inner last here gives me x squared minus 7x, so minus 14x. Negative 7 times negative 7 plus 49 is equal to 39 minus 3x. See x squared show up. Again, the prime time indicator that we need to factor. Let's add 3x over to this side. Let's subtract 39 over to this side. That gives me x squared. Negative 14 plus 3 is minus 11x. And then looks like we get minus 10. Plus 10, sorry. We can now go ahead and factor that down, just like we've done before. We need an x. We need an x. In order to get a positive number in the end, we definitely need two of the same sign. Since we're aiming for a negative number in the middle, it makes sense to have both of them be a minus. And we need a minus 10 and a minus 1 in order to multiply to that 10 and add to that negative 11, giving me two potential solutions of x is equal to 10 and x is equal to 1. We can now go ahead and solve that equation, or we can go ahead and check for extraneous solutions, right? We did say potential solutions because we need to make sure that we check when x is equal to 10. Is it true, going way back up to the top, that 10 is equal to 7 plus the square root of 39 minus 3 times 10? Is that true? Is 10 equal to 7 plus the square root of 9? I believe it is, right? Because the square root of 9 is 3. 7 plus 3 is 10, so I'm happy with that. I'm happy with that. How about when x is equal to 1? Is it true that 1 is equal to 7 plus the square root of 39 minus 3 times 1? I'm a little less convinced on this one. 7 plus the square root of 36. That's, I don't know. That's a bit of a stretch to say that 1 is equal to 13. Don't like it at all. We definitely have to say that this, therefore, is extraneous. But this problem does have one solution, and that one solution is x equals 10. Okay? Questions on how that was done? So today, what I was able to show you is I was able to show you a couple of word problems. I also showed you another little equation just to make sure we reviewed that as well. I'm going to go ahead and stop the recording here, but I do just want to talk to you a little bit about what our assessments are going to look like in the future. But our lesson is pretty much done here on that. So that's all I got for you guys today on that front. Again, stick around for just a minute or two because I do want to talk to you about assessments, and I want to hear from you as to whether you think that's a good idea or if you have any questions on the information that I sent out to you, okay? Other than that, have a great rest of your day, okay? Thank you.